All right, we're going to begin to talk about solving equations using addition and subtraction. Now, if you've looked at the Chapter 2 project, you will see that it's about balance. And the reason it's about balance is when we talk about solving equations, that's exactly what we talk about. We talk about balance. An equation has to be balanced. Whatever is on one side of the equal sign must have the same value on the other side of the equal sign in order to keep it balanced. So let's look at this example. 3 plus x is equal to 5. If I decide that x is equal to 1, it's unbalanced. It's heavier on the 5 side because 3 plus 1 only equals 4. So it's heavier on the 5 side. So it is not balanced. Well, what if I decide that x equals 3? Well, now it's unbalanced in the other direction because 3 plus 3 is 6, which is heavier than 5, so it's still unbalanced. But if I decide that x equals 2, then 3 plus 2 does equal 5, and therefore our scale stays balanced and our equation stays balanced. When we're doing equations, our goal is to isolate the variable so we can find the value of the variable that will keep the equation balanced. Now let's get down to taking our notes. So this lesson is on pages 84 through 88 in your book. Solving equations by adding and subtracting. So as I said in the little demonstration, the goal is to isolate the variable or get the variable by itself. And why do we want to do that? Because we want to find out what its value is. Now, the way that you do that in solving equations is to use what they call the inverse operation or the opposite operation. So the inverse operation for addition is subtraction. And the inverse operation for subtraction then would be addition. So how do we use this inverse operation to solve an equation? Well, first, you use the inverse operation to get the variable by itself. And you have to remember this rule. Whatever you do to one side, you must do to the other side. So for example, we have x plus 6 equals 4. We want to get the variable by itself. So that means that we have to get rid of the 6. Well, what is the opposite operation of this plus sign? The opposite sign is a negative. So a negative 6. But because we did it to this side, we have to do it to this side to maintain the balance. And what we see is this makes a 0 pair. And we have x all by itself. And this is negative 2, which tells us that x is negative 2. And I'm going to adjust that so you can see it. Now, you can check to see if you're correct. If we replace x with negative 2 plus 6 is equal to 4. Negative 2 plus 6 is definitely equal to 4, and 4 equals 4. So we did find the solution or the value of x. All right. Sometimes, though, you're going to get two signs together. And so it gets a little confusing. This is what you need to remember. Use the opposite of each sign. That's just the easiest thing to remember. So this is a positive, so I'm going to go negative here. This is a negative, so I'm going to go positive here. And so now we are going to add 43 to both sides because that's what's with it. So now what we have is E is equal to 88. And we can check to see if that's correct by replacing it. 88 plus a negative 43 is equal to 45. Well, we know that a negative added to a positive, because the signs are different, we subtract them, we find the difference. So that is 45. 45 is equal to 45. So that's true. And that's how you solve an equation using the opposite of addition or subtraction. Now let's go over to page 87 and do 3 through 11 to practice solving equations. So in the first part it says state the first step in solving each equation. Well, you want to get rid of the whatever integer is with the variable. So the first thing we would do for this one is subtract 8. And remember, we have to do what we do to one side, we do to the other. So we're going to have to subtract it from both sides. In number 4, 54 is with x, so we're going to have to subtract 54 from both sides. And in number 5, 19 is with c, so we're going to have to add 19 to both sides. In the next part, it asks you to solve each equation. And so you have to remember, of course, to do the inverse operation, or inverse what is there. So this started with a positive 6, so we did negative 6 to both sides and got b is equal to 3. For number 7, it was x plus 35 is equal to 15, so we removed 35, subtracted 35 from both sides and got x is equal to negative 20. For number 8, 3 was equal to n plus 4. 4 was with n, so we subtracted 4 from both sides and we got negative 1 is equal to n. Remember, always keep your information on the same side so you can follow it down and see what you did along the way. This one said d minus 4 is equal to negative 7, so we're going to add a 4, a positive 4 to both sides. So therefore, d is equal to negative 3. For number 10, it says c minus 34 is equal to 20, so we're going to add 20 to both sides. Add 34 to both sides. And so we should get that c is equal to 54. A positive 54. I made a mistake there for a minute. Okay, and last on 11, negative 25 is equal to q minus 10. So we're going to add 10 to both sides. And a negative and a positive, we subtract them and use the sign of the one with the greatest absolute value. So negative 15 is equal to q.